Hi, this is Jose Luis here at Parametric Camp, and welcome to another video in our series Advanced Development in Grasshopper. You may see that my beard is a little longer and I have more hair than in the previous video. There's been a time gap in between the recording of this video and the previous ones. I hope you don't mind. So, well, excuse me. What are we taking a look today? Today, this video is about loading external assemblies. And the idea is that in Grasshopper, just like in any other place where you can write code, the idea is that very often we rely on using custom classes and custom objects for the sake of transferring data between different entities and as ways of encapsulating data in objects that represent some kind of notion. So for example, in Grasshopper, we are very used to the idea of, for example, creating a vector using individual primitives, such as, for example, numbers with decimal part, that becomes an object that is a vector structure that has the three parameters that we can then exchange, multiply, operate with, or even deconstruct in some other component so that we get those initial primitives. But the idea is that the data that is being transferred between these two components is an entity, an object that is derived from a class, the vector3D class, that comes bundled with Grasshopper and with Rhino. A very clear illustration of that is if we were to replicate that same logic here, we would basically create a C# script component that takes three inputs, construct in Rhino Common to create an object, to create an instance of a vector, which we output on this component. And then this second component here, which is going to deconstruct that vector, takes in as an input, you can see that it takes in a vector3D object. And then once I double click, you can see that we have that object as a class here. And the outputs, we can just take the X, Y, and Z properties of this vector and output them. Okay? So this idea that we can use custom classes or custom structures to exchange complex data types between components and operate with them, it's the basic building blocks of object-oriented programming. It's a super common technique. It's the most common paradigm in modern computer programming languages, and you're gonna see it everywhere, basically. Now, we can use vector3D because it's part of the bundle, the Grasshopper plus Rhino framework that we're working with. And if you were working in Unity or in some other environment, you would have similar access to similar geometric entities. But what about if you want to supersede this and you're actually writing your own super empowered classes that represent some kind of notion that you're working with and that encapsulates a lot of data inside of it? What if you were doing that yourself, but you wanted to operate with your data in a similar way that we have here? You would want to exchange between components these custom classes, these custom objects that you are creating yourself. So we're going to see an example of that here today, which is going to be, for example, let me say that for some reason I am working with a class that I'm going to name a person. And the idea is that this person is made out of a bunch of particular properties, like for example, the name, the age, and whether if this person is a professor or not. Okay? In Grasshopper, in C#, what we can do is we can write custom C# script components that here on the additional custom code, we can write our own classes. So we can create a new class that is a person that has the three fields, name, age, and professor. We can have a constructor that takes that data and saves it in this class. And then we can have a string method, an override, to just create a more human readable form of this object. Correct? Now, if I were to do this and I wanted to create a person object that was output by this component, the first thing that I need to do is I need to go here. I need to make sure that the inputs name, age, and professor have the correct types. In this case, string, integer, and Boolean. And then here, now that the types are correct, what I can do is, like we've been doing in all my previous videos, we write the algorithm So for example, I'm going to define a person variable that is going to be called P, and it's going to be a new person with the value of name, age, and is professor. So that is the data that is coming in from the component. At this point, I can create this variable of the type person because I am defining what a person class is in my C# script component. All right. Now, what I can do is I can just output that over. So I can say person is going to be equal to this new variable that I just created. And if I run this code, what I get is this thing that is the person is Jose Luis, the age is 100, and whether if it's professor, it's true or false, and more or less age. So this is faithfully representing what the professor is. Correct? Now, the idea is that I want to bring this, let's say that I want to operate with persons and I could like mingle persons together, multiply them together. I don't know. This is just a theoretical example, okay? But let's say that I wanted to mimic this behavior. So I wanted to now have another component that takes an object of the person class and then is able to deconstruct it into its primitive parameters. So the name, age, and whether if it's a professor. The first problem that I encounter is that, remember how for C# script components, we need to right click and we need to make sure that the type of the input is the correct type so that we can operate properly with that object. If that is the case, then the first problem we run into is that if I right click on person and if I go to type hint, you can see that I don't have a type of person anywhere here because Grasshopper only gives me types that come with Rhino Common or that are primitives. So that is the first problem that I run into. So what I can do is, just for the sake of, I'm going to cancel the public override here. I'm just going to, what did I do? I'm just going to comment this out, all right? So that what we can see is that the type that is coming from here is something that C# stringifies into script instance plus person. All right, I'm not sure what that is. I will explain in a second. But the solution to that is that because we don't have an explicit type available to us, what we're going to do is we're going to choose the most generic type that's going to be system object, which is the type that all objects in C# inherit from. So the parent object is going to be always be system object. If I do that, then if I double click here, you can see that person is now this generic type. But what I can do now is I can say, well, inside of my Grasshopper script component, what I can do is I can cast this object that is generic into something that is customized, which is the type person. So what I could do is I could say, I'm going to say that the variable P of the type person has to be the input that is coming in cast to the class person. All right. So this is called casting, is when you translate objects from one type to another. I have a video on our Learning C# series where you can learn more about this, and it should be popping on a link over there, or there should be a card somewhere, or there should be a description, a link in the description. Okay. If I do this, this should work, but it will not, because what happens is that my component is complaining because the type or namespace person could not be found. It's just not accessible here. Why is that the case? Well, it turns out that this component, this one here, the one on the right, has no idea of what a person class is, because the person class has been defined in the other component, and because just like many other things, classes, when you define them inside of a component, they get scoped inside of that component, and they're not available to other components that are not inside of the same scope. So a solution to this could be, okay, well, I'm just going to copy all this code, all right? I'm going to paste it here, and now I have the same person class. I have the same person class in both places, okay? If I do that, that is going to solve some problems, but it's also not going to give me the solution, which is, and then the error that I get is actually really strange. It says, Cannot cast from person A to person B. Type A originates from this signature in the context load form. And if we look at the full error message, it's like a full, but type B originates in some other form and they're not compatible, etc., etc. What is going on here? Well, it turns out that what I just did, as logical as it might seem, it's actually not possible to do. It's not possible because the person class here on component A and the other person class in component B, even though they are both identical, they have the exact same text, they have the exact same properties, the code is identical to the letter. Even though that's the case, because of the nature of how Grasshopper works, because each component, each C# component is compiled internally in the background and it becomes its own thing. When each one of the two components are compiled, they get different signatures, they get different memory addresses, blah, 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 whatever. So even though the code is identical for both of them, because they get compiled in different places, in the eyes of the computer, they are different entities. They're just separate things, even though they have the same name, the same properties, etc. The computer is not able to see that because of compilation issues. So, because they're compiled in different places, the computer treats them as different things, and because it treats them as different classes, is not able to cast from one to the other. It's just simply not. Okay. What would be a good example for this? Imagine, I don't know, two cars that are identical but are manufactured by different factories, but every single atom that they do is identical. For us humans, we would probably be able to say that they're the same thing, but for a computer, because they're coming from different places, they're probably different types of cars, and it's not able to mix them together. That was not a great metaphor, but you get the point, what I'm trying to get here. Okay. So this is unfortunate because as a pro computational designer, you probably want to start working on libraries of classes and collections of objects that can encapsulate a lot of your really cool functionality that you're working on. And you may want to be able to exchange that information between different components. You may even create your own plugins that are running on classes and methods and functions that are customized by yourself. So what is the solution that we can do then here? Well, it turns out that in the case of Grasshopper, different platforms treat this problem differently. In the case of Grasshopper, this approach, copy pasting the same class in the two components, just doesn't work. There's literally no good way around it except for very complicated marshalling operations. It's just not good. So the actual good way of doing this is to take that code, extract all the goodness of your classes, etc., that you are customizing, creating an independent assembly, one that gets compiled once somewhere outside of Grasshopper, and then loading that assembly into your C# components, and then so that the same assembly is loaded by different instances, and because it's the same assembly with the same signature, all the components can exchange and marshal and cast that information without any problem. So how does that look like? Of course, I'm going to show you an example of that. Let's take a look at that. What I'm going to do real quick right now is that I'm going to create a Visual Studio project to create a library that contains a class of the type person, just like we wrote in C#. And I'm going to do it really quick because I actually have a full video here on my other list, on the Learning C# list, called Creating a Vector Class, where I actually go over the whole process of Visual Studio, creating a library, writing a full class. This is actually it's a really interesting video if you want to learn more about how to create your own libraries that can be reused in different places. So I really recommend you check this video out. A link will be popping also in a card, or it will be in the description of this video. You can find that out. Okay, so I'm going to go real quick. I'm going to create a new project in Visual Studio, not Visual Studio Code. It's going to be a library it's going to be a class library for the .NET. Where is .NET framework? Oh, okay. Class. This is for Windows Forms. Console application. Class library for the .NET framework. Okay, that was very far away. Class library for the .NET framework. I'm going to put this on my desktop, and I'm going to call this person class, for example. Okay, and it's going to be 4.6 because I believe that's a good version to work with Rhino and Grasshopper. And then here, what I'm going to do is I'm going to paste the code that I had in Grasshopper. Okay, so I'm going to save this. I'm going to rename this class. I'm going to call this person. All right, and then this is basically my person. This is a library that contains one class called person with the same properties that I had in C#. Okay, what I'm going to do now is I'm going to build this solution. And as I build that solution, that has created on my desktop. You can see my desktop has the full project person class, the person, and in binaries, in debug, I have this DLL person class that contains that code. Again, all of this I went over in my other video. So if you're interested in learning more, you can check out the other video. All right. So what I'm going to do is I'm going to now go to where I have my Grasshopper file, and I have no idea where that is. Let me look that up. Sorry. So I guess that's going to be here in advanced loading. Exactly. So this is the file that I had for this is the file that I have for the Grasshopper file that I have with the code that I was showing. Okay. So what I'm going to do is I'm just going to drop this DLL right next to the file, just because having DLLs, having assemblies and Grasshopper files next to each other just makes a lot of things easier. Okay. So I'm going to do that. And then I'm going to close this and I'm going to go back to my Grasshopper file. Okay. So you can see I'm going to actually copy and paste this somewhere else so that you can see that this is the one that doesn't work. And this is if you look at these files at some point in the future. So what I'm going to do is I'm going to remove from here, I'm going to remove that. I'm going to remove the custom person class and I'm going to remove it also from here. I'm going to remove it from both places. All right. Now you can see that the two components are complaining because they don't understand what a person is. The code used to be inside, but now what we want to do is we want to load that code from an assembly that is external. So I have compiled the person class in a library and I want to load it here. The way I'm going to do this is by right-clicking here, and you can see that C# script components have this section called Manage Assemblies. If I do that, what you can see is that it has this kind of environment where you can reference external assemblies that contain C# code. So what I'm going to do is I'm going to add here, and I am prompt already to the folder. You can see that person class shows up. Again, this is because I copy pasted the DLL right onto next to where my Grasshopper file was. And if I do this and I reference it, okay, you can see that now if I manage, you can see that person class is available on my C# script component. However, the code is still telling me that the namespace or person could not be found. Why is that? I just loaded it. Well, it turns out that loading an assembly and referencing the assembly are two different processes. So this integrated development environment, this window here, has access to the person class because it loaded the file, but it's not using it. And because it's not using it, then this code is not working. The way to use that is to expand this area that we have on the top of the C# script component, where we are loading all the external assemblies that this C# script component is using. It's using, as you can see, some default system libraries. Is using the Rhino and the Rhino geometry namespaces, and it's using a few other namespaces that are coming specifically just from Grasshopper. Okay. So the idea is that here, what I can just say is I'm going to use the person class namespace that I defined for my library. And if I run this code now, I believe it should actually work. Yes. So instead of writing using person, I need to refer to the namespace. And the namespace is this thing that shows up here. So if I had a lot of different libraries, a lot of different classes in the same namespace, person, cat, dog, whatever, they would all be loaded by just loading the namespace. So as I use the namespace, then person as an entity becomes available. And then you can see that this component all of a sudden starts working. What this component does here is, well, we have the same problem here. So let me first reference the assembly. So I could load it here, but because I loaded it before, I can just use the same one. So I'm just going to go to the recent ones and drop it here. And then now I have the same problem, it's not available anymore. So what I can do here is I can say using person class, for example. And then as I do this, you can see that no errors are found anymore because I can effectively convert from the person object that was coming to my component, which was a generic object. I can convert it to an actual person class because, again, the person that I'm loading from here, it has the same signature that the one that was generated by the other component. And then just as simple as that, I can say outputs. Now name is going to be p.name. What was it? Age is going to be p dot, and you can see how the autocomplete is already giving me all these nice options because it's picking them up from the compiled library. So I get age, and then whether if is professor or not is going to be p dot is professor, and then ta-da! So now if I change the inputs or if I change the professor, I'm not 45, okay? I'm 100 years old. So if I change that data, then this data changes correspondingly because there is a properly flowing connection between the two components with a class that is recognized by the two components because it's coming from the same assembly that I compiled myself externally. All right? Ta-da! So this might seem trivial or a stupid problem to have to deal with, but it's a problem that derives from how C# gets compiled in computers, in operating systems. But it's something that sometimes we have to deal with. However, my invitation to you is to consider that this that we have learned in this video is actually quite helpful and very good practice, because if instead of copy pasting code between different components, which is something that is very difficult to manage, if what you do is, as a general practice, you start abstracting code that you write yourself that contains all your power, all your really cool algorithms, if you extract it into entities that are standalone and can be exchanged between any different software. In this case, if you extract them as a DLL in C# that can be used in Grasshopper, but also in Unity, in VVVV, in any other C# based environment, then your code becomes more reusable, more resilient to changes, less error prone. It's actually a really, really good practice. And this technique is also at the core of how other people use external third-party libraries to improve their code and to make it more powerful, or how people create third-party code and offers it out to the world for other people to use it. Okay, this is it's like a super, super common practice, and I, for example, have written a bunch of C# libraries myself that people are using out there in the world. Okay, and I constantly use them for my own practice, that libraries that other people have used and have contributed to the community. It's a really, really common practice. Okay, so I hope this was useful. And in order to further illustrate this idea, what we're going to do in the next video is that we're going to do a hands-on example where we're going to program a bunch of custom components that do mesh operations, like remeshing, reducing the mesh, etc., etc. But instead of doing it manually ourselves, or instead of doing it with the capacities that Rhino Common gives us, What we're going to do is we're going to use a third-party library, so a DLL that we're going to download from the internet that somebody is giving us, and we're going to use that to extract, to use its functionality, but embed that functionality into our Grasshopper components. This, again, is really the basics of how modern plugins, for example, in Grasshopper are developed. So if you're interested in learning more about that, check out our next video, mesh components and how to import third-party libraries and use them to your advantage, okay? In the meantime, if you thought this video was useful, maybe consider liking the video, maybe subscribing to the channel, and maybe even hitting the notification button to get to know when we publish new videos, we go live, or just leave a comment and say thank you because this was nice, or say that this was a terrible video and why you think so. That's also perfectly fine, okay? Thank you very much and see you on the next video. Bye-bye.